Alright, so here comes the last two problems. The integral, or the antiderivative if you would like to say, of secant to the third power x dx, and the integral of cosecant to the third power of x dx. So before we move on, if you didn't watch the last two videos about the integrals of the other four trig functions raised to the third power yet, I would suggest you to actually have a look first, because we actually start from the easiest and then getting more and more challenging. And now we're actually getting into the final parts, which are, in fact, I would say is actually a lot trickier than the first four, because the first four are actually quite direct when we try to solve it, meaning that we don't have to actually do something that is a little bit tricky or kind of like crazy ideas to kind of like throwing the stuff back and forth, other than just using a few of the trig identities that we actually have learned in trigonometry class already. So now when we actually move to the last two, we actually need to use a slightly different strategy in order to solve the integrals on the board. So before we move on, you can also pause the video and try yourself first. Done? Are you ready for it? Okay, here we go. So let's do the first one, and because it's going to take more space, I'm going to erase the second one and then put it back on later. So the first one that we're going to do is the integral of secant to the third power of x dx. So what are we supposed to do? Well, if we're just trying to use the same old trick that we actually used for the previous integrals, that's simply break it into secant times secant square, we actually will get the following. We have secant square of x. Then if we actually follow the same trick, we would like to turn the secant square into, of course, by the Pythagorean identity, we will turn this into 1 plus tangent square. And after when we multiply the secant in, we're able to distribute into two different integrals of secant of x dx plus secant of x times tangent square of x dx. Now we already have found the result of what the integral of secant of x is, but for the other integral that we have, we would like to think of doing use up like what we did in the previous videos. But in this case, if we try to do a use up, we now need to think what u should be. Now, if we try to assume that u is tangent, then our du will be secant square. But we don't have secant square here, because in fact, if we try to rewrite it, we actually get tangent times sine over cosine, or sine times secant, so that we actually get the second copy of secant, but then we actually have a sine remaining. Now on the other hand, if we try to let u be secant of x, then if we try to take du, or take the derivative of u, then du will be actually equal to secant x tangent x times dx, meaning that we need to think of the derivative of secant of x, but then in that case, we also need another copy of secant. So we don't have it. In fact, this is what we're supposed to do after the first step. So instead of trying to use the trig identity to break secant square into 1 plus tangent square, we can actually use the DI method, or some people would just call it RIP method, however you call it. Anyway, if we're going to use the DI method, then which one will be the part that we're going to integrate? Well, we know what secant of x is if we try to integrate it. But we also know that secant square of x, if we integrate, it will get something even better. So we might as well just let our u be secant of x, such that the remaining part will be our dv. Then by the di method, we'll actually get u, which is still the secant of x, times the integral of dv, which in this case will be just tangent of x. Good. Then we are going to subtract our v here, and then times du, which is the derivative of this part here, which in this case will get secant square. No, you will actually get secant x tangent x dx. Good. Why is that good? So first, this part is already solved in some sense that we have no more integrals. So we have secant x tangent x here. Now for the second part, we have secant of x times tangent square of x, because we now have two copies. But now we can actually use the trig identity by replacing the tangent square in terms of secant square. And in fact, we actually get this be secant square of x minus 1. So it means that now as we rewrite it, we actually can get the first part not integral anymore, minus, now we will be able to get, as we distribute it, we will get secant to the third power of x dx. Then we'll have minus a negative, which turns into positive, of secant of x dx. And as we see that in the right hand side of the expression, we have minus of what we start off with. We can actually now call this integral I here. So we're going to continue into the next board. Okay, so in the last board, we actually end up to the right hand side, so that we actually get the expression secant times tangent minus the integral of secant to the third power plus secant to the first power. And we can rename it the initial integral here, integral of the secant to the third power as I, so that we can abbreviate it, so that now we actually get the expression on the right hand side in green, and we can actually move the minus I on the right hand side of the expression to the left by adding it, such that we actually get 2I is equal to secant of x times tangent of x plus the integral of secant of x dx. And again, it is something that we have done, and it is not something that is fundamental, but hopefully you will actually memorize it so that it will be very handy when you need to use it, which is actually equal to ln of the absolute value of secant of x plus tangent of x. And don't forget, since there's no more integral, we need to put a plus c here. Or we can actually change any c into anything, because again, c is just a constant, but it's arbitrary, meaning that we can use c to refer to any number. So we can also rewrite c into some other dummy variables, or we can just rewrite it as some other numbers times c. So in this case, I'll rewrite it as 2c, such that now we can divide both sides by 2 to get that I, which is the original integral here that we started off, which is the integral of secant to the third power of x dx is now equal to half of the right hand side, which gives us 1/2 of secant x tangent x plus 1/2 ln of the absolute value of secant of x plus tangent of x. And finally, we just have plus c, so that the two will be cancelled out. That's it. So this is how we can actually get the integral of secant to the third power by using the DI method, as well as trying to substitute or replace the initial integral into some variable, so that we can actually treat it like an equation and move things around to simplify and find out what the integral will end up to be. So last but not least, we have cosecant to the third power, which in fact will actually act the same way that we did for secant to the third power. So here we go. We are going to do the same trick by first breaking cosecant to the third power into cosecant to the first power times second power. And instead of using the trig identity to replace cosecant square in terms of cotangent square, we're going to do the use the DI method, and we might as well just call this integral at the beginning as, again, I, or you can use any dummy variable. And if we use the DI method, of course, we will just try to set our dv to be the second part, because if we try to take the integral of it, it will become very nice. Instead of trying to taking the integral of just cosecant to the first power, which of course we know what the result is, but it doesn't look as neat as taking the integral of cosecant square. So if we do that, we will end up with the first part, or u, times v. In this case, it will be minus cotangent of x. And don't forget there is a minus, right? Because the derivative of cotangent is negative cosecant square. So it's, since we have positive here, we need to put the negative down here so that we will match up. Then we're going to subtract the integral of this this v part here, which is negative cotangent, but in this case we can just leave we can just change our sign up here into positive. Then we're going to take the integral. No, we're going to take the derivative of u, which is, again, the derivative of cosecant is negative of cotangent times cosecant, or you can put it the other way around if you want. And don't forget we have a dx here as du. Then we're now going to simplify the expression to get negative cosecant x cotangent x. And then now we see that there is another minus sign here, so we are going to pull it out. So we have minus the integral of cotangent square of x times cosecant of x dx. And now we're going to use the trig identity and replace cotangent square into cosecant square minus 1, such that we will get the first part that is no longer an integral, we'll keep it the same, minus, now if we rewrite it as cosecant square minus 1 and distribute it into distribute the cosecant into it, we will get cosecant to the third power of x dx. Now we have to minus the negative, which is plus the integral of just 1 times cosecant dx. And again, this here, the middle part, is something that we call I here, such that we'll be able to move it around or bring it to the left side, and then we will be able to finish it off. And we're gonna finish up in the next board. Okay, so we just end up to the following result, and now we just need to play around the algebra so that we'll be able to figure out what I is, which tells us what the integral of cosecant to the third power of x dx is. So doing that, we'll just put the negative I on the right hand side to the left by adding it. So we will actually end up with 2 copies of I, which equals to the remaining parts in green. That says negative cosecant x cotangent x, and then plus the integral of cosecant x dx. And again, you can just either go to check, find it from my old video, or you can just try to memorize it, which will be beneficial. That when you need to use it, you don't have to try to figure out everything again. And the integral of it is negative ln of cosecant x plus cotangent of x. And don't forget, we have no more integrals, so we need to put this constant term plus, again, we can just call it 2c, such that at the end, as we divide everything by 2, we will get the integral that we start off, which is the integral of cosecant to the third power of x dx is equal to negative 1/2 of cosecant x times cotangent of x minus 1/2 of ln of the absolute value of cosecant x plus cotangent x. And then finally, plus 2 divided by 2 is 1 times c. And that is it. All right. So that's all the integrals of the third power of trig functions. And hopefully you all enjoy it. And don't forget to like and also subscribe to my channel so that you can find out more of my other videos. Don't forget to turn on the notification next to the subscribe button, so that whenever there's a new video, you won't miss it. And if you have any thoughts, you can leave your comments down below. I'll see you guys next time.